I've finally got most of my stuff wired, so in this video I'm going to walk through the low voltage wiring system. So the source of the low voltage wiring comes from the output of the battery controller box. High voltage comes out there, and then this is my DC to DC converter. So at the same point where these high voltage outputs come from that box, I have wires running to the input of my DC to DC, which go into the back end here. And then these are my output. So I have it set to, you can actually turn this little screw and set it. I think I have it about 13.5 volts because that's what this voltage says for this little auxiliary battery. So this is 13.5 volts output here. So I have all of these running in several leads because I couldn't get thick enough wire in just one pair. So I have several of these leads running to this unit here. This unit is quite nice. I got this off Amazon for like $15, $20. It's got a main positive, main negative bus. And then I have all these labeled for all my things. All of the positive legs you can put individual fuses in, and all the negative legs go off the common negative bus. What's really nice about these is if it's very easy to route, and if you blow a fuse, actually one of these LEDs will turn on so you can see which fuse you've blown. So I've got all of these labeled. So this leg goes to my battery, which is my 12 volt battery here. I don't have it plugged in right now, but that would go there. Technically I don't even need this because if the controller is always on, that means I always have high voltage to here, which means I always have 12 volt output. This is really here in case anything happens, like the controller cuts off, I'll still have 12 volt power from this battery here. If I didn't have a battery here and this DC to DC failed while driving, there would be no energy source remaining, no 12 volt energy source remaining to close this contactor with the key. Voltage is gone, that would just open up and I would be stranded and not able to drive. So this is kind of just backup insurance that I'm able to drive if this ever dies. It also would be nice to put a little 12 volt monitor here to run to the dash so I can see what voltage my 12 volt is at. Kind of if this screw ever backs out while driving from vibration, I could see if there's like a too low voltage, 11 volts or something. I would know there's an issue and can come fix that, resolve that. This 12 volt positive I have marked, this is going to the existing vehicle wiring 12 volt. I still have some things to figure out there to get the headlights, brake lights working. This video I'm just talking about the new to the system 12 volt low voltage wiring, all the EV stuff. The only other thing I've tapped from the original circuit wiring of the car is this white wire. When I turn the key to, I have that labeled position 2, so first click, this gets 12 volts. So I have that running to this black end, which runs to the throttle I have here, and then the red end runs out along here to another white wire, which eventually runs, like I mentioned before, to the key relay, which eventually runs to the controller and turns on the controller. So there's a micro switch on the throttle just to make sure that like when you turn the key on, the throttle isn't active right away in driving. So that's what these wires do, essentially completes the key circuit through the throttle here. This other wire here is the throttle output, runs to those two red terminals, and that's the input to the controller to tell it how much power to send to the motor. This other white wire with the blue terminal, that is the key coming from the relay. So the key turns the controller on, and then that senses how much power to send it. This here is my 5 volt that runs to right here, which is a 12 volt to 5 volt converter. This is a better angle over here. I have two things running off of this 5 volt converter. First is this wireless router, which is how I send the communication from the BMS to the display inside. Then the other is the display inside, the power, which is this gray cable you can see right at my fingertip there, and that runs inside. Here I have my speaker. That's for the speakers hooked up inside the car. Those also run through the wall. It's quite the disaster in here. I've just started to pick through and label what each individual thing is in the stock harness. But like I said, there's two things coming out of the wall here. One is the power for my speakers, which then run there. This runs off of Bluetooth. I have a video earlier about this. And this other gray cable is the USB to power my display screen. The rest of this will be figured out, getting the headlights, turn signal, all this functioning. That's for another day. And then here is BMS. BMS is this control box. I need to supply 12-volt power to it. So all these legs are appropriately fused for the amount of current that they will be taking. And lastly, I have the EVSE. That runs to this board here. This is a Dragonfly board. I got this from Eric Polson on the DIY Electric Car Forum. He actually sent this to me for free to test out. This controls the proximity pilot of the J1772 connector to be sure that I'm getting the proper signal that I can charge at public charging stations. So that takes in 12-volt power, and then these are the 3 signal wires coming from the J1772. So for this board, I just 3D printed a small enclosure with 4 threads on the bottom. I put a standoff on the bottom, and then I have a little lid here that I close it up with. And that, again, you know my methods, that is just velcroed to the side here. So here I got a brown wire for prox, orange wire is pilot, and then this yellow wire I actually have running to a relay here. This is a relay for the key. So what this does is, if I'm charging, this relay is essentially opened, and this relay is connected to my key switch, which then runs to my controller. So when the relay is opened, no power gets to the controller to turn on the controller, so I can't drive away. So that's a safety feature, because you wouldn't want to drive away with your cord plugged in, because you would break things. With the key out, this relay is closed. So this is a normally closed relay, and when it's energized by this yellow wire, it opens. It's closed, the circuit flows through, and I can drive. I'll post info of this in the description. I really like this. This is a simple board. It's labeled very well, obvious what to do. And this kind of competes with the EVSE 2 boards that you see for sale, I think from Thunderstruck for about 50 bucks. Super simple, and I now have full J1772 functionality. Overall, this looks like kind of a rat's nest. But really, most of what's going on is here for the EV. All of this is relative to the original car. None of that is relevant anymore. And there's a lot going on here. This relay on this side, this relay on this side. It looks like chaos. It probably could be cleaned up a little bit and routed better, but I have everything labeled, and so it's very clear what's going on, at least to me. I'm not an electrical engineer. I've never done any sort of wiring before. I'm sure that shows, but this was simple enough for me to follow and produce a working circuit for the car with everything being fused properly and safely. And honestly, my wiring up in the front doesn't look much worse than this Lucas OEM stock harness going on here. I'm gonna have to spend some time debugging, troubleshooting, just to make sure all my switches and everything is getting power and ground, and I can work all of the original OEM accessories of the car.